require a few things. One of them, though, would be getting rid of all the parentheses. So I'm going to go ahead and multiply this out. That way we've eliminated the parentheses. Secondly, I want to try to get it in a y equals form. Try to get y by itself. So if I try to get this to where I have y by itself, we're going to try to get all this stuff to the other side. So I'm going to do that by subtracting the 2x squared. This is negative 2x, so I'm going to end up adding 2x. And I guess that's it. All right, so I have this now. All right, so graphing form we know is going to be a form where we have y equals a times x minus h squared plus k. So if I look at this one right now, I've got that negative sign out in front. So I'm going to pull that out. I know that's really going to be my a value. I just pulled that out of those two terms. And at this point, now I can start trying to complete the square. So I'm going to take half of that 2. When I square the 2, or sorry, square the 1, I end up with positive 1. But then I've got to multiply it by this negative that's out in front. So now I have negative 1. Well, I was supposed to have 0 because there wasn't anything out here. So I'm going to have to add 1 to that. So this would be my graphing form of that equation. Now we can start picking out some things. One of them was the locator point. So that'd be our vertex. So our vertex here would have been at 1, 1. Another thing was the x-intercept. So to find the x-intercept, that's when y equals 0. So I'm going to take this equation and I'm going to set it equal to 0. So we've got this. And I'm going to try to solve that for x. Well, if you wanted to multiply it out, you could, but maybe a better strategy here would be to subtract 1. Then get rid of this negative by dividing by negative 1. And then what might I do at this step? Instead of multiplying it out, I can do that. I can multiply it out and see what happens. How can I get rid of that square root?
You can do square root.
Yeah, I can square root both sides. Here's where you had to be a little bit careful. I'm going to have x minus 1 on this side. But if I square root that 1, I could have had a positive or I could have had a negative 1. So I really have two answers here for my x-intercepts. I have, when I add it to the other side, 1 plus 1 or 2. Or I have 1 minus 1 or 0. So I had two x-intercepts on that one. Luckily, the y-intercept is going to be a lot faster because all we got to do is plug 0 in for y, or for x, I mean. And when I plug 0 in here and here, I find out my y-intercept is 0. So I had x-intercepts at 0, 0, 2, 0, y-intercept at 0. Okay, so there's a lot going on in that problem. We'll make sure that we put on all that stuff. Another one from one of the previous assignments was this one. There was 4 parts to this problem, but part D wanted us to find the x and the y-intercepts. It actually gave us a hint, and it said refer back to part C. What I'm going to show you, though, is something that you could do with this problem that we haven't really done yet before. And again, it said go back to part C, and that made it a lot faster. But if I want to find the x-intercepts, for instance, a lot of times with x-intercepts, in a situation like this, we try to do some factoring of some sort, but we haven't really factored when we've had 4 terms involved. Well, there's a strategy with factoring that's referred to as factoring by grouping. And when you factor by grouping, if I have 4 terms like I do here, I'm going to group 2 of them up at a time. So in other words, I'm going to focus just on those first two terms. Well, if I asked you, what do these first two terms have in common? Is there a common term those two have? Did you? Yeah, x squared. So I can pull an x squared out of both these. If I were to do that, I'm now going to be left with x and then a minus 2. Then I look at these two, the negative x plus 2. Well, at first glance, they really don't have anything in common. Other than I could, if I wanted to, take care of that negative x by pulling out the negative, as long as I do that to both terms. So now I've got this situation. I've got x squared times x minus 2. And then I have minus the quantity x minus 2. Well, if I thought about this being one term, this being a second term, well, they both have something in common. They both have an x minus 2 in common. So let's say I pulled out the x minus 2. Well, if I were to do that, I'd have an x squared left on that term. Minus, and even though we didn't write it there, we know there's a 1 there. And so now I have it in factored form. Except if you notice here, x squared minus 1 is one of those difference of squares we talked about the other day. Because x times x gives me that. 1 times 1 gives me that. So I could break this into x plus 1 and x minus 1. And we already had the x minus 2. And that was actually what part C had for all the factors there on that one. So I didn't expect you to know how to do factoring by grouping, but I wanted to show you an example of factoring by grouping. And then you can find your x-intercepts because it would be a positive 2, negative 1, and positive 1. All right, so just an example of another factoring strategy. Then this one popped up on the one that was due the other day. And this is one I was talking about in math help, I think. Giving you a notation we didn't necessarily talk about. But if we look at this problem, this is really what we'd have to do in order to factor it. I'd have to come up with something I can multiply to get 18, but they would add up to give me that k value. So the first thing I'd ask myself is, well, what are some things I can multiply to get 18? Well, I know I could do 18 and 1, but I could also use what? I'm just 18 and 1, but 2 and 9. What else can we use? Now, I looked at the positive examples of all these. What else could we use though?
You do negative 18 and negative 1?
Yeah, I could do all the negative situations too. So this could have been plus or minus. This could have been plus or minus, as long as they match. They're both positive or both negative. Same thing here. And same thing here. Well, in order to find k, I now would have to add those two things together. So if I had 18 and positive 1, I'd have 19. Or if I had negative 18 and negative 1, I'd have negative 19. So k could equal either a positive or a negative 19. So that's what we'd get when we'd add them. Same deal here. When I add those together, a positive or a negative, in this case 11. And then here we have 6 and 3, so it could have been plus or minus 9. So any of those could have been our k values on that one. But the big thing was just remembering we're multiplying to get this value, and then we're adding to get that one. And then the last one was one of the ones that was due today. This was part B on 175. Today's problems were actually all closure problems for chapter 2, so they're all kind of review problems. But this one wanted us to find the equation of the exponential. So we're going to try to fit it into this equation. So the strategy we said works the best is usually plugging in the x and the y values to create a system. So I'm going to take that second equation where y was 25.6 and x was 2. And the second situation where y was 50 and x was -1. And we said in order to solve this, we were going to divide those two equations. So when I divide those two equations, first of all, I'd have 0.512. The a's would cancel. What would I have, excuse me, for the exponent on b? Yeah, it's 2 minus the -1. And so now I'm going to do the cube root of that. So when I do the cube root, what would I get? Wait. And then remember, we're going to just plug that back in to figure out what our a value is. So I can plug it into either equation. If I plugged it into the first one, I'd be looking at this. So I'm going to divide that 25.6 by 0.8 squared, and I get 40 for that. So our equation on this one, we should have gotten 40 times 0.8 to the x bar. All right, so again, just a few that I wanted to clarify, make sure that you're understanding on that. All right, well, what I'm going to have you do to begin with